Hi everyone, my name is Sanjana Agrawal and I have done my B.Sc in Physics from Delhi University and Master in Physics from Maharishi Dayanand University, Rohtak. So today we are going to understand the topic of Law of Conservation of Energy from chapter number 11, Work and Energy. And at the end of this video, we will be able to state and apply Law of Conservation of Energy as well as analyze how energy is conserved between kinetic and potential energy. You all must have heard that energy can neither be created nor be destroyed. It can only be transformed from one form to another. If it can neither be created nor be destroyed, why do we study the types of energy? Because it can be transformed. Let's discuss few examples. An automobile converts the chemical energy of fuel like petrol, diesel, or CNG into mechanical and heat energy. A tree converts the light energy from sun into chemical energy. A mixer or a grinder converts electrical energy into mechanical and heat. Also, a lamp converts electrical energy into light as well as heat energy. Not only this, we have a very good example on a bigger scale too. What do you think of a hydropower plant? Let's discuss about hydropower plant. So as the law of conservation of energy states that whenever energy changes from one form to another, the total amount of energy before and after transformation remains the same. Here we have the hydropower plant. You must all have noticed that the dams are built across the river and at a very large height. So let's have a look at the complete and the structure of a dam. Here we have the reservoir of a dam where a large amount of water can be stored. Now because it is lying at such height, so it possesses a high potential energy. And when the water is released from the reservoir, it falls down with a very high velocity. And because of higher velocity, it possesses higher kinetic energy. Once it reaches the ground and strikes the turbine, it starts rotating. And due to the rotation of turbine, the generator produces electricity, which in turn generates the current and is transmitted to the city to the transmission lines. So this is how the concept of dams are built. Have you ever thought that the water means the hydro energy can be converted to electrical energy? Now we will understand the mathematical formulation that how the energy remains conserved between kinetic and potential energy. Consider an object. Let's consider a ball of mass m which is resting at height h of a building, and there are three figures you can see: the instant 1, instant 2 and instant 3. Because it is at certain height from the ground, it is supposed to possess potential energy, and once we make to fall it freely due to velocity, it will start possessing kinetic energy. Now we find out the total energy at instant first. As you can see, at instant first, the ball is resting at height h and it is not in motion. So according to the formula of potential energy, we get the formula mgh, and it is lying at the maximum height. So it has the complete potential energy, and kinetic energy has a formula half mv square because it is not in motion. So velocity is 0 and hence kinetic energy at this instant is 0. So total energy will come out to be potential plus kinetic, that is equal to mgh plus 0, and the total energy at instant 1 is mgh. Please do note this. Let's name this equation as number 1. In the second instant, we'll make it fall freely from this height. And the second instant is the case when the ball is in the middle of its journey, where it has fallen down from certain height h. Let's say it has covered the distance x from the topmost point, and it is somewhere in the middle of its journey. So it is possessing both the types of energies in instant second. Let us mathematically see how. The distance covered by the object is x, so remaining height from the ground is h minus x, and hence potential energy from the formula will be mg into h minus x, which is the remaining height. And kinetic energy has a formula half mv square, but here we have to find the velocity by using third equation of motion. I hope you remember v square minus u square equal to as. This is the case of motion towards gravity, towards the earth. So we'll take acceleration as g and the distance which it has covered starting from the topmost point of the building, which is x. So we get the value of v square as 2gx. You have to substitute this value in v1 square. After substitution, we get the value mgx. So total energy comes out to be sum of potential and kinetic, that is mg h minus x plus mgx, and the final total energy will be mgh. Please do note it is coming out to be the same as in case of instant 1. So let's name this as equation second. Now we'll find out the total energy in instant 3 with the same method. The third instant is the case when the ball is about to reach the ground. It is about to strike the ground. So all of the height has been reduced because it is just touching the ground, and the kinetic energy will be maximum because in case of freely falling body, the acceleration keeps on acting on the body and its velocity keeps on increasing. So let's mathematically see again what total energy will come out to be in third instant. As the height is 0, has become 0, so there will be no potential energy at all in case third, and kinetic energy will be half mv square. Again, by the formula, that is third equation of motion, we need to find out the final energy, the final velocity of the body that it is possessing. V square minus u square equal to gh. But this time the ball has covered almost whole of the height h, so distance covered will be taken as h and not x. And here we get velocity square equal to gh. Let's substitute this value in the formula half mv square. We get the kinetic energy as mgh. And after summing up the two values 0 and mgh, again we get the total energy as mgh. And so you can note that total energy in instant 3 also is mgh. So from equation first, second and third, total energy, that is a sum of kinetic and potential energy at every instant, is constant. And hence we can say that energy is conserved during transformation. So this is how the energy transformation takes place in various actions that are happening in the surrounding, where the energy can be transformed from one form to another, but the total energy at different instants of the action remains the same.